Hello, my name is Noah, and I'm going to share with you some work related to using computer vision methods to analyze and examine the gaze patterns of neurodiverse learners as they watch 360-degree or spherical video-based virtual reality videos. This work was done with my colleagues Matthew, Heath, Wanley, and Carla, and collectively we represent the University of Missouri, the University of Florida, and the University of Cincinnati. To begin, I want to talk to you about autism spectrum. As I mentioned, this work is concerned with neurodiverse learners. In our case, we're focusing primarily on autistic learners. So to begin, I want to tell you what autism is. And autism is a neurodevelopmental condition that impacts approximately 1 out of every 54 people in the United States, though it is important to note that this figure may be higher as improvements in diagnostics and the celebration of the neurodiversity movement has helped to bring attention to individuals that may have been left out of past diagnoses. Also of importance is that autism is considered to be a spectrum disorder that is often associated with frequent comorbidities such as epilepsy, anxiety, ADHD, sensory processing challenges, and OCD, to name a few. Which means that if you have met one person of autism, then you have met one person of autism. While autistic individuals do exist on a spectrum, there are still a number of pervasive socio-communicative challenges that arise due to societal constraints and accessibility issues, and there are significant provision and support barriers that lead to issues with autistic individuals receiving a high-quality education, finding meaningful employment, living independently, and maintaining interpersonal relationships. So as part of this project, the entire work here is presented within an application known as Virtuoso SVVR. So to begin, Virtuoso itself is a virtual reality intervention that was designed for and in collaboration with autistic adults enrolled in a day program at the University of Cincinnati. And the program has a goal of providing year-round curricula around promoting vocational social opportunities. And the goal of this Virtuoso intervention was to provide training related to catching public transportation in and around the campus setting. So Virtuoso used a stage-wise instructional strategy that progressed from simple to complex across a spectrum of low-tech and high-tech tools. This included beginning with an introduction to the skill, usually presented in a piece of multimedia like a comic. Number 2, 360-degree video modeling of the skill. Number 3, the rehearsal of the skill within a fully immersive virtual reality scenario. And number 4, actually going out and practicing the skills to see how the skills generalize and transfer to real-world settings. Now the focus of this paper and the research here is on step number 2, which is the modeling of the skills which took place within Virtuoso SVVR. And then within this application, we presented 4 360-degree video-based scenarios that walked learners through the skills they needed to know to be able to catch a bus safely and appropriately. So as we were doing this, we started to think about some questions that we might be able to answer. So the research questions that we have at this time is, how can computer vision algorithms detect variation in usage patterns of autistic and neurotypical users? 2, what usage patterns emerge as users watch videos within a SVVR system? And number 3, how do usage patterns compare and differ between neurotypical and autistic users? So to answer this, we wrote a custom Python script where we split the SVVR videos into image stills, and we basically ran it through an image detection algorithm through YOLO version 3 and Image AI, and put it all out into a spreadsheet. And we are currently using a variety of analysis techniques to kind of see what patterns emerge. At this point, we're using Markov chains, sequential pattern mining, and entropy analyses, though this is very preliminary and we're still exploring what we can do to examine how learners are actually engaging with spherical video-based virtual reality systems.